Good afternoon, everyone. Thank you for joining CPCI's webinar today on accelerated building construction. My name is Ariane Sabourin, and I'm CPCI's marketing manager. I will be the facilitator for today's session. Today's webinar will be presented by Ken King from Hanscomb Limited. For the past 41 years, Ken and Hanscomb have been very involved with the construction and real estate development industry across Canada. Professionally trained and qualified as a quantity surveyor, Ken has 2 diplomas in urban land economics from the University of British Columbia, 1 in appraisal and 1 in real estate management. He has also presented programs featuring mortgage underwriting skills, consulting skills, public speaking, and management techniques to institutions such as Canada Mortgage and Housing Corporation, Business Development Bank of Canada, and the Certified General Accountants of British Columbia, just to name a few. Ken has successfully delivered quantity surveying, project management, and development management services to a wide range of P3, public and private sector building projects. Because of his ongoing commitment in promoting the advancement of building technologies, Ken has been a keynote speaker for the U.S. Green Building Council. He is currently writing a course for BC Housing on emerging building technologies through Langara College and was recently the independent certifier for the Surrey Biofuel Project. So without further ado, I will now turn it over to Ken King for the presentation.
Thank you, Ariane. Hello, everyone. I've got the great honor of being able to make this presentation today, working with CPCI, which I thank very much. CPCI are major players when it comes to the accelerated building construction method of construction, and Precast Concrete is central to that. So without further ado, I'm going to get further on with this. ABC really stands for Accelerated Building Construction, and it's a real paradigm shift when it comes to project planning, design, procurement, construction, and commissioning. And it gains the benefits of minimizing mobility impacts for on-site construction by setting pre-construction processes and systems to a higher priority. This ABC shift allows for realization in intrinsic benefits such as lowering your capital costs. We've seen this on numerous projects by as much as a third of the cost. Shortening overall timelines, dramatic improvements in project scheduling just by organizing everything through ABC. Improving site safety and security, absolutely felt with regards to how much actual materials are on site. It's very minimal. Everything's done off-site and installed. Gaining project quality because we have a greater quality control with the accelerated building construction. We actually end up with a better project overall. Enhancing project durability. Usually the products that are being brought to site are designed to be more robust because they are transported, and as such they're built with endurance and durability in mind. They offer more opportunity to engage new technologies into the projects. A lot of the technologies that are burgeoning today for construction really would require installation at a factory level or at a properly controlled institute level. This is going to lead to huge benefits with regards to energy saving and other advances that are going to make these buildings much more functional. They do reduce long-term operational costs going through that process, even just staying with standard technologies. And we also limit our social impact costs, such things as traffic and noise goes way down. And of course, we limit the environmental impacts in the short and long term. Properly designed ABC projects are also fully reusable and repurposable, really taking a lead with regards to how we deal with construction in the future and how we can reuse these valuable resources rather than just burying them or throwing them away. ABC improves complete design integration. So much of the work is being done by the subject matter experts with regards to the materials that are going in, that it makes it easier for the design team to know exactly what they're going to get and how it fits together. So site constructability goes up. All the details, all the details as far as fit and finish and how things connect are all done and organized before you ever get to site. Site security during building is actually easier. There's, because these projects involve larger elements, they're very difficult to steel, and they're designed and packaged in such a way that vandalism is pretty well eliminated. The total project time gets much shorter. We've seen time savings of up to 50% of site-built projects, so it's quite significant. Project zone safety for workers and the public alike is much better. We have fewer areas where safety is at risk, and in many cases, the way the projects are developed and built, they're actually designed to work outside of being affected by the elements. So pretty well, you get to button up or close up stage very quickly. Project durability is improved, of course, and you do have access to these technologies, which you find very difficult sometimes to incorporate into site-built projects. What it does reduce as well are areas with regards to interference with the public. Quite often you can schedule your deliveries of your major elements in such a way that it's at the lowest levels of traffic, and peak traffic flow and noise is absolutely minimized. In fact, many of these large elements go in very, very quietly. There's very little noise and bother on site, so interference with the public is very minimal. Traffic impacts, as I mentioned earlier. On-site construction time is drastically improved. The project that, one of the projects that I was involved with up in northern Alberta, it looked literally like the project was growing in front of your eyes. It was going very quickly. Material wastage is pretty well minimized or eliminated altogether. We don't see, the one project we did in for each building, we had one disposal bin for the entire project. It only had to be emptied once during the entire project. Most of the product came up and was installed without any additional dunnage or wrapping. It just went straight in. Laydown areas, staging areas, and storage areas are all minimized. If you've got a tight site, you don't have much room, ABC can be an answer for you with regard to that. Weather-related time delays are pretty well almost eliminated, if not entirely eliminated. The project we did in northern Alberta was able to continue construction. We only had to stop at times when the weather got below -40 Celsius, and that was because the crane wouldn't work very well. And I'm being asked some questions right now. We'll get back to Q&A later, but I'm going to come up with some case studies that are later on in the presentation that will describe this. I'm just hitting the summaries right now. And the other question that we're seeing, will this webinar be available for viewing after the session is complete? Yes, we are going to be recording it, and that will be passed along later. So we'll get to these questions more later on. And the last part, of course, is financing and borrowing costs go down. If you can return your money to the bank faster, they often are in a hurry to lend it to you. We found that there was no shortage of people wanting to lend us money on ABC projects. There has to be, once they understand how the project works and how the timelines work, they realize that turnaround for their construction funds are faster. The banks have more available resources to you. They're more competitive, and we see interest rates and costs overall going down. So let me play you a little video here of what the occupiers, owners think of these buildings, not knowing that it was an ABC building, a modular building. In fact, they have no idea.
Hi, I'm Licia Mullings, and I'd like to take you through our home. Bright colors provide stimulation in spaces specifically designed for dementia residents. Doors are paired together like duplexes with colored porches to provide a wayfinding experience. Upstairs are 6 supported living neighborhoods, each with its own dining space and servery. There's ample room for relaxing and spending time with friends and family. Our residents love the abundance of natural light and the warmth of the interior finishes. Central care stations offer a clear view to all residents' front doors. Each neighborhood has 33 private suites, including some for couples. Come inside. Each has its own kitchen, television, and barrier-free washroom. Secure gardens provide a safe outdoor experience.
It was interesting to note how much she spoke about this modular construction having lots of light, open space, very welcoming. Quality of finish and fit was just right up there. ABC Construction absolutely does very well with regards to the highest level of quality of project you could want. So where did ABC really start? Well, actually it was really pushed by the U.S. Department of Transportation and their Federal Highway Administration section. They use a lot of accelerated building construction with regards to the assembly and construction of things like overpasses and bridges. And even major sections of roadways were installed in modular sections through concrete panels being put in the ground. This is now, of course, transferred into the area of building construction, and we see modularity becoming a very important element of the future for all types of construction. Here's a model project that was going to be constructed in Fort McMurray, and the opportunity here was to build something that was quite light and quite airy, would create a very strong visual sense without the feeling that you're just putting together boxes. And this would really demonstrate how open and light a modular project could be. You'll note that there are some elements of the project that have a more traditional look, the ends are especially, and that was done purposefully to give it a visual anchor, a structural feeling of solidarity, while the open and light airiness space is all throughout the center, especially creating whole surfaces of light and color that really were attractive to this space. This was achieved under this design with developing 3 solid cores of modular precast units that were designed to stack together, lock together. And then the cores, and then between the cores, we had these vertical structural elements that were put up as part of a skeleton. And they're held up temporarily by those little thin green lines, which are temporary steel beams. The intent there was to build a skeleton on site so that we could really fast track this project once we got to the finishing stages, the fit out stages, where the entire units would be fitted out. So the project would have been built to the roof, and then a structural diaphragm would have been put on and roofed at that time. And that created our watertight shell once the units came to site. The units came to site fully finished. This is just a graphic of what they look like, and they were designed to be inserted into the unit. So a crane would lift them up and insert them to the unit. And if you notice, these units were designed where the ceilings were exposed, and the floor of a unit would actually be the ceiling of the unit below. So everything is designed to be plug and play mechanically and electrically, and counterintuitively, we actually start the construction from the roof and work our way down. This was going to produce, we expected we'd be able to put up to 20 units a day in using this means and method, and all the mechanical and electrical systems were connected at the corridor side. All that was left to finish on site was just the corridor floor and ceiling finishes. Everything else was panelized and finished in such a way that it was part of the unit as it was going in. So we ended up with a very efficient system, and there's still plans to move forward with this. The other project in Fort McMurray that we actually did end up building was the Eagle Ridge condominiums. And this was built back in 2006, and the developer at the time wanted to try this out. So they started with one building. It was 150,000 square feet and 6 stories tall. It had 1 level of underground parking. We were able to produce a completely finished shell on that project within 55 calendar days with a crew of 6. I was one of them, and I basically sat in the truck most of the time. There was a crane operator and 4 iron workers. And at the end of the day, the cost on that project was about 2/3 what they expected to pay. We ended up with these photos that you see here. You can see at the top row of photos how clean the site is as it's going up. We ended up doing all 9 buildings this way. And the outside finishes are quite spectacular, and they actually did really well with the fires that were on up there. There was absolutely no damage that was perceived with regards to these buildings. I think they had the roof burn off one of the units, and that was just replaced, but the units themselves were undamaged through the major fires that they had up there. It was so much successful with regards to the buildings. We applied the same principles on the ABC process, and where they had engineered an overpass to be put in for steel, we went to a modular format for the overpass across Centennial Way, and we were able to do the same type of structure at a fraction of the time for $6 million as opposed to 20. Inward, of course, you see these units. They're as good as anything that, in fact, it's considered still one of the best quality projects that you do find in the Fort McMurray area. The fit and finish in that is extremely good. We found that when the interior trades were going in to do their work, they had very little concern with regards to making things fit. You know, you don't always get square and true walls in a site-built project, but you do in these ABC projects. So it made it much easier and faster to complete the rest of the installation. And had we moved forward with more of these projects, we would have brought the units up fully finished and just installed them there. Now, it's interesting to see what architects have to think about these projects, so I've got another video.
I'm Christopher Babbitts from FWBA Architects. The decision to build with precast concrete informed the design, and our approach was to turn limitations into opportunities. Concrete surface treatments and creative use of color, texture, and depth enabled a 4-story design to harmonize with a 2-story neighborhood. A hollow core floor system, together with innovative delta beams, offered us the thinnest floor structure possible. A 4-story design was achievable within the zoned height restriction, which maximized the land value. As architects, we are always looking for performance, durability, and sustainability. These locally manufactured concrete panels may look like wood or stone or stucco, but have a radically longer anticipated life cycle. This is a place for people.
I think it's very important to remember that regardless of what we're building and what we're building with, it's always focused on the user, the people that will be using it. And the nice thing about accelerated building construction is that it delivers that so many ways. So here's a few of the case examples I want to go through. Out in Point Towers, Phase 5 of the Barrel Yards in Waterloo, Ontario, we had a developer who had started their project as cast-in-place concrete towers. But the project was starting to get delayed and costs were starting to rise, so we had a pretty savvy owner on this project. And they stopped one of the towers, they had a number of towers they're putting up, they stopped one of the towers about after the 3rd floor, and they actually went back and spent 6 months redesigning this unit into a modular precast unit, and they let the other tower carry on in cast-in-place concrete. So you ended up here with each of these towers are 25-story. You got 357 living units in each of these. You ended up with one being built having really a head start, continuing construction. Once that switched over to the redesign for the precast and they started up again, it actually beat the other tower by 4 months. So it surpassed the, even with the delay, it surpassed the construction time of the site-built project. You ended up with really an iconic bit of construction, and the rest of the project all went modular precast because of that. And again, you'll notice how clean and how well organized these sites are in a modular format. Normally we would see with any type of site-built construction a lot more storage and activity on site. Actually, all the activity is where it needs to be inside the buildings, and it's going up very quickly. So it's a very clean, very efficient, very affordable, and fast system to build with. In this situation in Kitchener, the designer wanted to go with something that was really make a strong statement on the skyline in Kitchener. And so they built these 3 distinctive modular towers for the Kitchener area. And you'll notice that by using the modular system, they were able to put some very dramatic geometric shapes on the outside. And we're seeing elements of that here in Vancouver with one of the towers that are going up downtown. They're about 14 stories tall for building A. B and C were a little bit smaller, but they all went up fairly quickly. Building B, for example, was started in March and was completed to the top floor by May. And each of these buildings, the total floor area for all three buildings was about 40,000 square feet. So these were no small buildings. They weren't as big as some of the other ones like the previous project, but the cost economy and the time savings were spectacular. And of course, the quality of finish and fit was just spectacular. Another example of some of the elements that you can see in this. And of course, one of the largest elements were these modular decks that go on the outside, and you can see them in this one photo right here. So they were the heaviest elements, and that they went in fairly easily, and it was a fairly quick process as far as getting this project up. So this turned out to be a real opportunity to showcase how accelerated building construction can lend itself to really advanced design systems where architects really want to make a strong statement. We'll bring that up again later. On this site, we had to really speak to, on a modular construction, we really had to speak to the heritage of the area, but also a site that absolutely had no free space. 7 stories tall. You got a number of 1 and 2 bedroom units, 73 of them, ranging from 530 to 800 square feet. And you've got, each floor is about 9,000 square feet. And each exterior wall was being installed for every floor within 5 working days. And the nice thing about it is they came out with this ready, already built look. So they came out completely finished. You had a really strong sense, and yet we were able to provide that sense of attachment to the heritage nature of the neighborhood. There were about 64,000 square feet of floor area, modular floor pieces that were put in. All the stairs and concrete landings were modular, all 25 flights of concrete stairs. You had all modular concrete columns and decorative cornices. This basically went together like a large Lego set, and did so without taking up any land space of the site, because there was no land space for the site. The benefits with regards to doing something like this also in a tight city area is that traffic and everything was considered, and all the deliveries were done in such a way as to minimize the amount of effect that you would have, or the construction would have, on the neighborhood, and therefore made it actually quite a reasonable project as far as moving forward and doing projects in a tight urban setting. Now, contractors really like that ability to have that flexibility working on site. So let's hear from the contractor.
Hi, I'm Kevin Juby from Manshield Construction. We built this. The way this project was designed allowed us to construct faster than conventional methods. Our mechanical and electrical trades, which are key to the process, were on the first floor snapping lines and starting rough-ins while the precast on the 3rd floor was being built. This system provided us an enclosed structure and a controlled environment which afforded our teams maximum productivity through the winter months. I believe we have helped Covenant Health set a new standard for care facilities moving forward.
It's very interesting that today we've moved even further along beyond that. You see, a lot of these modular projects are now coming together with all the fittings and fixtures already in the units, and they're being installed that way. But even with the most basic shell construction that we've showed examples for, the cost savings, the improvement in quality, the time savings are spectacular. A good example of something that's quite interesting, where it doesn't look like it would be a traditional modular construction, is the Quarry Park project in Calgary. And this one here, we're looking at something at a real French provincial design. Not everything's a straight line. And that works very, very well in a modular setup, because the ability to create true curvature, standard, consistent forms and shapes, and maintain that high level of quality is really exemplified in a modular format, because that's all done in a factory setting where you have that quality control. Not only that, it doesn't cost you, or doesn't cost the project in time or in cost. You can actually get many of these benefits ahead of time by just doing some proper planning. Again, a very visible site right by the river's edge. Concern was working around a site like this where, you know, potential construction activity could cause siltation in the river, and of course you're right in the middle of a residential area that's quite you know, popular and busy. Again, they want to have something that's as least trouble as possible. So these 4- and 5-story projects with these really unique upper levels, it really required special attention to the building envelope system. And the building envelope system came as part of the entire structural wall. So you had 86,000 square feet of R20 insulated exterior walls, and the windows were already installed. All these windows in these manufactured settings are smoke tested, which you don't get on site, and as such you get better quality construction. Everything's designed to fit tighter. The basic system that we have here allowed this project to be built right up against the green space, minimal interference with the community, no interference with the green space, and in a very short period of time with very little fuss or bother. Going into Quebec, we have a project here that really does exemplify the minimalist, ultra-modern look. Again, obviously this seems to be a natural bend with regards to modular construction, because modular does lend to that kind of a cubist look. But it is a hybridized project where we're actually working with different materials, not just precast concrete, but other modular systems that are designed to enhance the abilities of other different modular systems to work together. In this case, they wanted to have this building put together fairly tightly, fairly quickly, and they wanted to have very, very minimalist look. So they didn't need any, they didn't want any beams that were below the ceiling level. So they went to a product called Delta Beam, which is a finished base steel beam system, modular beam system by the Payco Group. And it provides a slim floor slab where the precast modular floor systems and the Delta Beam that knit together actually make a pretty consistent single level floor ceiling system. And then they used also an advanced slender wall precast system for the building envelope to create more space with minimal amounts of structure to interfere with that space. You can see in the picture up on the left upper corner, you can see on one side a finished building, and you can see how open and how much space is available to you with this type of system. It's fully modular, and it gives a lot of ability to create some very interesting, beautiful, iconic open spaces for living in this. Also would lend itself very well to office construction. Here you see a more detailed installation where the hollow core slabs are being netted together with the Delta Beams. These Delta Beams are designed to work with hollow core. That's why you have all the portals in the Delta Beam, and it makes it's a great hybridized system with regards to how these go together. So how does this typical floor progress? Well, in day one, you'd be installing all your composite columns in the Delta Beam systems. In day two, 6,000 square feet of floor goes in. On day three, another 6,000 square feet goes in, and then on day four, you're just topping off. So in 4 days, you're able to come up with a completely finished floor, all your walls, your columns, everything's in there, and very quickly you're following behind with regards to your exterior curtain wall and building envelope systems. I have another quick question coming in. I'm just going to look. The sound transmission with the Delta Beam hollow core system actually is pretty beneficial as far as I understand. You still get all the benefit with regards to having that mass, with regards to keeping the high frequency sounds in. The Delta Beam doesn't impede that in any way. It works as a very good system. The concrete topping that goes onto it helps also deal with just distributing and keeping the transfer of low frequency sounds through. So actually a modular system, hybrid modular system like this actually is a very good system with regards to making a quiet building a very good space and really minimizing the transference of sound either through vibration or through just normal noise within a space above. Certainly high frequency sounds would be dealt with. This is a really interesting photo down here in the right-hand corner. We haven't even put the topping in yet, and you can see how we had specialty module pieces put on the outside to create these shapes of the balconies, but you can see how well manufactured this is. This is actually very, very flat level floor. The topping would just be the final finish off, but it created a very solid, very tight, very high quality form of structure that performs very well today with regards to it being residences, but certainly would make an ideal office. Now, a lot of people say, well, how small can you go with modular construction? Interesting, especially if you're looking at doing something quite unique. They built a house in Calgary called the Woodland House, and this is all modular precast concrete. And it turned out to be a huge benefit. One of the concerns, of course, in this area is what do you do with fire? And, you know, you're pretty close to all the trees, and how do you make something that is, you know, that's going to stand up well and be a good, long-lasting product. What makes this very interesting, that this project was a fraction of the cost of what they were expecting to spend for a custom home. It was quite a bit less cost-wise to do this in a modular format, have it shipped to site and put together, rather than, you know, doing more damage with regards to interference on the site and building on site and doing something that, you know, would have been a standard custom home. So they were able to take the approach with regards to using modular format and put it into a smaller scale and get the benefit of it. There were 2 stories to this project. It was 4,100 square feet, very ultra modern. You'll notice that from the outside it has a very kind of a practical, almost a neo-industrial look. What you end up, though, inside, you get these polished concrete walls, polished concrete stairs. Lighting is often part of the modular system itself. You end up with these very large open spaces, and it really does allow that counterplay between the natural surrounding around the outside being able to be brought in and, you know, counterplaying against the very clean, very ultra-modern, minimalistic look with regards to the modular construction. It was about 40% less to build a project like this. They had soundproof walls that were rated to R20 and R45 for the roof. In fact, it was up to R50. Basically, you ended up with a top-of-the-line project that was 40% less than what they expected to spend, and they ended up with something that was far better and more long-lasting than what they were expecting to get. I've got a new question in here. What do engineers typically do to withstand the shear in the hollow core and delta beam buildings? I'm not an engineer, and I wouldn't pretend to be one, but they have means and methods to have, it's in the detailing with regards to how they're connected. I know that the delta beam has a fairly large flange in it, and therefore much of that shear is dealt with just on the modular design, hybrid design for delta beam, and it's designed to work specifically with hollow core. So it's a real opportunity and advantage to kind of put something together here. You can do something. I can't answer your question in detail, but if we had a structural engineer that worked on it, they can get into some of the details. But I know that they have ways of working and bridging that. And the delta beam is designed to really work with dealing with the shear on those sorts of matters. Now, of course, we've been talking about precast concrete, so I think we should probably hear from the people that do the precast concrete. And it's interesting because in this graphic, in this video, you'll actually get a real feel on how quickly things go together. And it's not quite as fast as this video, but it isn't far off.
Armtech Precast found a need in the continuing care market for a fast and sustainable construction method. Our solution begins with an insulated sandwich wall panel, which includes an exterior concrete skin with variable finishes, a continuous layer of insulation, and the load-bearing structure. Having the structural mass of concrete inside the insulation enhances the thermal storage properties of the wall. The pieces are built off-site in a controlled environment, with tight quality control. The beauty of the design is the repetitiveness of the construction. After it's coordinated through a BIM model, it's like putting together a Lego set. We were able to build the shell of the building in no time at all, allowing the contractors to do their work inside. And while one wing was being built, another crane was already starting on the second wing. The precast construction continued from the main floor to the roof and included all pre-stressed hollow core slabs, columns, delta beams, stairs, elevator shafts, and the wall panels. We were able to construct the building in 4 months, compared to conventional construction time of 16 months.
So, I mean, obviously precast concrete is a natural product with regards to accelerated building construction. I don't want to make it sound like I'm just selling for the Precast Institute. You know, I'm obviously a fan of the product, but there are other materials out there. But this is basically why we're seeing the hybridization of different materials that come together to allow accelerated building construction to move forward. In fact, the first modular building material that was really out there was masonry. Bricks, by the way, were one of the first. In fact, Great Wall of China is made of brick, and it's still there for a very good reason, because humans naturally want to find easier, better ways to do something, build something with quality. So there's a lot of history in this. You might recognize this photo. This is from the Expo site in Montreal. This is Habitat, and Habitat's all modular precast construction, and it's actually a world heritage site because of that. It did prove the approach as being a real advantage in moving forward on the future of construction. And many of these pieces are actually interchangeable. So, you know, these modular prefabricated elements they basically replace the in situ site construction. And you can imagine how difficult this project would have been had it been built on site, considering the number of places where it spans over open spaces, the amount of safety, extra rigging, scaffolding that you have to go into doing this. Actually, this went up with almost minimal involvement with workers on the outside of the space. They actually were able to connect it all fairly quickly. So because you're using modular prefabricated elements, you do address these critical groups of activities and consider you know, all the fundamental or comprehensive elements in that are important. So in 67, this was completed in 1966. This became an icon with regards to Canada's Expo in 1967 for the World's Fair. And as I say, it was a real historic monument for the Quebec government, and it really showed how precast in a modular format could do it. Now, again, the Canadians aren't the only ones that have done this. I've got other questions coming in. I'm just going to take a quick look. Are the R20 walls nominal or effective value? That's a detail I don't have an ability to answer right now. We'll come to that later. I believe it's an effective value, but it's pretty consistent in that where there's very little thermal bridging with these systems. So another project which is quite famous, in fact, it becomes one of the things to do when you're in San Antonio, besides eating at their wonderful restaurants and doing the Riverwalk, is the Hilton Palacio del Rio Hotel. This project here, 21 stories, is built fully modular, and it provided a project. It's, as I say, it's part of the tourism attraction. It was 230 feet tall, had 496 rooms. When it was under full construction, it was putting in 17 units a day. And there's a photo of what that looked like back then. And the principles are still there. The materials have advanced way beyond that, but the principles are still there. And it's still considered one of the icons of San Antonio, and they make a big deal of it as one of the big things you want to go see, because this project went up with a very small crew, very quick, and the manufacturing plant was just 8 miles from the site. In fact, the intrinsic values left over by these projects where they institute ABC is often businesses are retained in the area. They really improve the economy of certain areas. So one of the things that ABC does promise is an opportunity to provide additional economic benefits long term. Where you start with all this is you have to start at the beginning. It sounds very obvious, but what we do is we develop a project charter. And in that project charter, we make the financial and business case work around ABC construction. It's very difficult to make ABC work, although we have examples of it, but it's very difficult to make ABC work when you think about it as an afterthought. The best benefits come if you start from that point and work forward. And there are enough successful opportunities with regards to doing that you have all sorts of examples. So you do your business case, you get the unanimous support of the entire project team, and you basically bring everybody along to think in the same way. So it requires the development of a project charter, which everybody signs on to, especially today with the new energy codes and step codes. It's actually getting easier to require people to sign on to that project charter to get the benefits of ABC, because you can realize many of these code required needs can be realized with ABC approaches. You have to have your project team that are familiar and comfortable with taking on this approach. And it's also an opportunity to really build new and stronger bonds in amongst the team to really develop a better, successful relationship moving forward on this and future projects, and to also create a better link to those who are going to end up owning and operating the building later, knowing exactly where it came from and how it was developed. You have to do your business case on the basis of modular construction. That means your cash flows are going to be a little bit different. Deposits are usually required for many of these projects, but those deposits can be secured in such a way that any lending institution would be satisfied that they aren't actually, paying a pig in the poke. They're getting some value for anything that may not be quite installed yet. There's quite a bit of sub-tendering going on, where you'll pre-tender out major parts of this even before the general contractor or the project manager or the construction manager are organized on site. That's because the principles of what you're doing will be well understood by the project team, and some things can happen in different sequences so that you end up getting what you need when you need. It's not unfamiliar for people who pre-order certain materials, things that are strategic. It's more of a strategic approach that you're taking. And of course, you have to do something called job order contracting. And that is a little bit different with regards to how you move forward in your procurement of the project, but it's actually pretty logical when you think about it. And it is a matter of just having the structure set up and the payment system set up such that it can support modular construction and the development of manufactured products being imported to the site and basically installed on site. So why are we doing, it's also one of those things with regards to the integrated design process, which is very popular. Now, we all understand the principles of integrated design. In traditional project delivery, we wait for the architects and the engineers to all get done, and then we start building. And then once we start building, we realize, oh, we've got some issues, and we have to go back and make changes. It tends to add cost, and it tends to add time to make that done. It's better to think about this earlier, have everybody on board early, and this is where ABC really shines, because by its nature it requires integrated design. And as such, a lot of this stuff is not only you have to think about it earlier, but the systems are designed to make it easy to think about things early. There are certain, the accelerated building construction develops systems that are designed to knit together naturally. You're not forcing anything. So when you do the job order contracting under this process, it's basically a collaborative construction project delivery method, and it enables the organizations to get numerous commonly encountered construction projects like schools and hospitals done quickly. So what you'll end up doing with job ordered contracting, if you're working in the either large development phase or if you're working for public sector, is you may have a group of projects you all do at once, and you order from a common supplier for certain types of things. And then the integrated design process works with this with these resources that they weren't available to them before, and they can actually end up with better projects for less money and less time. So an ABC IDP project will always provide better quality, will provide a better quality outcome for less money and in less time. And that's especially important when you're doing larger overall developments, or if you're doing kind of a continuous stream of developments like governments do for schools or hospitals or any other projects where you may reuse the same principles. It doesn't mean your projects all look the same. It just means you're using the same core principles and how things are developed. On the procurement side, we use subtendering and job order contracting, and it helps reduce the unnecessary levels of engineering design. Because what that does mean is if you go into a process where you want to get something built with ABC and you're using the job order contracting, you're transferring critical elements of the design to those subject matter experts. So it's still incumbent on the design team to sign off and understand what's being put together, but those who really know how these products go together actually do the design for you. This not only saves money because it's important that you're not duplicating the works of somebody. In fact, you're actually doing the shop drawings before the engineering is actually done. You do it the other way around. But it also gets into a situation where it saves time. So everybody's working in parallel, knowing how everything knits together, and the contractors are doing the engineering with their own engineering teams to make sure everything fits. Coordination of this is far simpler than you would think, especially if you work directly from the project charter. Value, of course, is very important, and ABC does deliver that. It relies heavily on incorporating these modular units in there. Because it does save time, because it does save money, it does improve your quality, improves your durability, and it does give you unparalleled access to these burgeoning technologies that are coming in there. A lot of these modular pieces can be made in such a way that you can retrofit some of the technologies or upgrade some of the technologies if it's been thought out ahead of time. This is very important with regards to various P3 designs where you have a design, build, finance, and maintain process, especially for those that are in the DBFM P3 format. The maintenance issues improve, the costs can go down if you can continually upgrade a building like you used to be able to upgrade computers and get better performance for less money. And this is one thing ABC can provide. So it can be used in the design and construction, and you can also make permanent or movable facilities. It depends on how you've engineered something. And again, this is one of the things that I've been really promoting, the opportunity to use permanent or semi-permanent structures. We're seeing a lot more use of semi-permanent structures here in the area where people are putting model projects up for residences. And that's moving forward. I see I'm running a little late. I'm going to hurry this up. So a question came in real quick, and I talked about the resistance to earthquake. Modular construction actually is usually engineered and designed to, because of the way they have to fit together, the resistance to earthquake and seismic loading can actually be superior to on-site site-built conditions. And that's because they actually have to take extra consideration and care for this. So it'll perform as well as anything that you would typically site build. It's all in the detailing and the connections of the various units that are going in. Let me just, I'm running a little long here. This is a project that we were doing in Fort McMurray. This one here, this was one of the first ones. They actually came more finished. You notice that we had plywood in front of the windows. It turned out actually we didn't need to protect those windows. The way they shipped up, we didn't actually need to cover them in the future. They were completely sheltered from the rocks. We had very, very little breakage of windows. In fact, we had a lower percentage of window breakage that had to be replaced than if you had had a site-built project. Though, again, I mentioned earlier, all those windows that went up in these insulated wall panels that went up in Fort McMurray had all been smoke tested. That building is extraordinarily energy efficient. In fact, it's quite it's so energy efficient that one of the things we noticed when we were on the site, one project's built up against basically a highway, and across the road from it is a fire station. And we were there watching the fire engine going, the lights turning, and seeing the traffic go by, pretty busy. Couldn't hear a thing. We had to open the window to actually hear the engine go by. So it was quite spectacular. If you've got that kind of sound quality, sound improvement from outside noise, you're certainly going to have that benefit with regards to thermal performance, and we've seen that in this building. If you'll notice here how clean this site is, these pieces were literally going up, you know, in a few minutes each time. So we would come to the site every day, and these trailers would be dropped off. The tractor would go and pick up another trailer or take an empty back, and these panels were going up. And you can see in the foreground, you have floor panels and wall panels. That was going up very, very quickly. You'll see somebody maybe up on one floor. Very few people around. You don't really need a lot of crew to put these in. They go in very, very quickly. They literally work a very quick time frame. And the way the delivery worked was very much in tune with the just-in-time supply chains that we see being really put forward. So you don't have to have a lot of storage elsewhere to put this up. This actually comes around pretty quickly. It's you end up with a cleaner, safer, more secure site, more efficient, just because you have this modular approach. Again, logistics is the key. You have to be organized. It has to be done right up front. Quality control is a big issue as well. Here we have a set of, we actually have some engineers from out of town on this project looking at the site and looking at the quality, fit, and finish, and it was pretty exceptional. We can do all this, of course, in the factory. And of course, all these panels are designed to be protected or managed in such a way that even during erection or transportation, there isn't any sort of damage. We saw very, very little marking or damage from these panels as they were going up. So you get a very high quality finish. You also end up being able to do some very interesting things with finishes and textures on these panels that you can't traditionally do in on-site construction. Occupancy commissioning and turnover is much faster with an ABC construction. A lot of stuff can be pre-commissioned with the new modular systems that are going in. So all you're doing is just connecting the plug-and-play nature of the elements as they're going in. Again, final turnover of an ABC project is usually just a matter of course, and often the inspections and approvals have been done elsewhere. You're not seeing much in the way of inspections on site by those authorities having jurisdictions. Operating costs are quite a bit lower. We've done, or actually CPCI has done life cycle assessments on precast concrete buildings in a commercial sense, and they've turned out to be very, very favorable. So you end up with a product that works very well, very energy efficient, easier to maintain. Sustainability, in this case here, these are wall panels that were salvaged from it was a Canadian Tire, and it was repurposed and put into a community center in Quebec. So this is going to be the future. Eventually everything will be universal modular pieces, and you'll be able to swap them around and put them on different projects. But this had significant cost savings for this community center, and it did keep a good portion of the building, the Canadian Tire building, out of the landfill. So 50% of these walls were basically reused. And I did a project years and years ago for the city of Vancouver where we proved the principle that you can build with used material. Nearly 90% of that building was used materials. And again, it was the forerunner of where modular was going to go. So in conclusion, a precast concrete ABC modular construction basically has some real advantages over anything you might build on site. It's worth considering a different approach. Properly engaged, any kind of ABC project can actually bring huge benefits to that project, especially in the long term. So it basically also allows you to bring in new technologies that you really want to incorporate into your project. And it's easier to do so with a modular ABC approach. So on that note, we're talking about a new time paradigm shift. I'd like to open up to questions, real questions. I've been kind of picking through them as they come up. So the last question I talked about was the shear and the, okay, so earthquake. Next question, with regards to precast concrete, is it prone to water ingress? So traditional precast is prone to water ingress, but this is not traditional precast. Again, the detailing that goes into the ABC approach for the precast that's being used here, the edge details and so on are actually more complex and are designed to seal tighter. So again, you've got an industry that's really championing the modular approach for construction, and as such, they're thinking through all these details as far as water ingress, air ingress, anything else. So you actually end up with a better quality building. So it's all a matter of moving forward with regards to, I'm going to put these up now. I've been talking about them before. So basically, it's all a matter of improving the detailing, the technologies, and ABC does produce this. My next question, are you doing a 5-centimeter topping above the hollow pre-stress elements? I can't see concrete on the site. Well, we haven't shown the topping. The topping is still being used on the hollow core. In the future, you're going to see modular systems where that topping won't even be needed, and you'll actually have embossed finishes in the floor. So there'll be some opportunities to respond to those finishes and really improving this. Again, we're talking about something that is changing the industry, and that in itself is going to create a change. Next question. OAA insures, here, okay, we're going to do this live. OAA insurer insists that we are not insured if we do not use drained rain screen system for the whole wall, not just the joints.
Ken, it's Brian Hall from CPCI, as I'm one of the panelists. That is actually not true. There's an exception for precast insulated wall panels.
There you go.
Yeah.
Because I was going to say, I don't know of that being.
Yeah.
Every time I've used sandwich panels, it's never been the issue. So yeah, I think we're probably covered with that.
Yeah, and just to address a question before about water ingress within precast wall panels and so forth, if you look at the major firms across Canada, building envelope firms across Canada, and if you look at the OAA, indemnity insurance and so forth, there's never been a major problem with precast panels and so forth. The only water ingress can be between the joints and so forth, even though there's a lot of joints. These joints, it's a dual stage system, and the moisture is basically wept to the outside of the panels and so forth. So if you talk to anybody at the OAA as far as the pro indemnity insurance or RDH building consultants or any of the major building consultants across the country, we have not seen a problem in the last 40 years. And we do have, by the way, a brand new best practice guide that has been produced for precast concrete, which will be running seminars across the country. And we also have, that'll be launched in the next few weeks, we have a thermal calculator that will help you calculate your R factor of the whole building envelope. So, and that'll be launched probably in the next few weeks.
So Brian, the question came back, there's no exception according to John Hackett. So that might be a discussion you may have to have with OAA.
I will definitely talk to John about it. It's actually, if you go in the guide, there was an exception for precast, and whoever, sorry, and for the disagreement, if you just want to email at info@cpci on that, I can send you the documentation on that. So
sure. Okay. So Brian will take a look at this, Martin. Okay.
Yeah.
Our fiber reinforcement. Oh, here we go. Are we using fiber reinforced polymers in the precast concrete elements? Depends on the manufacturer and their approach. They have other systems as well that create a very high strength, lightweight concrete system. So there might be other systems in there. I think that's probably just one of the choices that they're using. But again, every manufacturer has a different approach.
Yeah, exactly. And Ken, just to follow up on that, one of the big things in the industry and research has been done by CPC, high performance insulated wall panels.
Right.
So what we will be doing is reducing our 11 or 12 inch insulated wall panel down to 5 or 6 inches and so forth. And of course, there are all types of natural fibers, plastic fibers, steel fibers that are used in ultra high performance concrete.
Right. And I want to return to this comment I made earlier. These technologies are still moving along. And what's exciting is the fact that we're applying this in a modular format is accelerating the materials science and the technology. So they're ending up with smaller, thinner walls, lower cost, faster installation. This is, again, you know, it's the approach that we're pushing here. If you take the right approach, you're going to start seeing a lot of these benefits. Will there be better benefits in the future? Absolutely. But, you know, it's still better than what you're building on site today. Are there examples of single-story buildings? Yes, the house was a good example. That was 40% lower cost. You can expand that easily, and that could easily have been a single story. I did some numbers for a project that's planning on doing a number of seniors houses, individual seniors houses where they're 1 and 2 bedrooms, 1 story, and we were looking at costs in the US where they are able to supply and install a completely finished shell, which they would fit out for about $55,000 US. So we're looking at numbers in the US that are quite aggressive and quite good. And they're putting those things up in 2 days.
Yeah. And Ken just actually mentioned that the industry has also been working in research with developers across the country and so forth that creating track housing for single family housing and so forth. So, which would include precast basements that again, that you can install within a couple of hours with hollow core floors. And then basically what you would have is probably 25 different panel types. From those 25 different panel types, you probably have in the area of about 9 or 10 different designs for track housing. So
yeah,
that's probably not going to be in the next few years, but that's something we can really see coming down the road.
Well, I think it's happening faster than you think.
Yeah, probably.
We're seeing real acceleration. I've done the time motion studies on it and the stuff that I've looked at inside of Texas, and some real interest in moving forward in this area. Has there been life cycle assessment for GHG carbon emissions for this type of construction? There have been bits and pieces done. I think that I'm in the middle of doing a number of GHG studies right now for different types of projects. This is worth a separate study, considering that if you make the product such that it is completely reusable, your GHG carbon emission drops off to nothing, because if you can use that panel, and in theory, these panels could last 1,000 years, you captured all that carbon that went into it. You're certainly going to outlive a tree. So there's some opportunities here in this as well. It just hasn't been fully researched yet. But again, by doing the ABC approach on any of these systems and making them in such that you can completely reuse them over and over again, that's where the future is for sustainability and for energy efficiency and carbon capture.
Yeah, true. Actually, just a quick example of that, we had a parking garage was owned by the city of Kelowna in BC, and that parking garage was taken apart because they needed to build, it was only a 2-level parking garage, and they needed to build a new one, and it was taken and it was put in the city yard, all the double T's, columns and beams in the city yard, and it sat there for about 5 years, and then it was used for parking for a community center in a very dense area of Kelowna. So
Martin's asking
used over and over.
Right. So Martin's asking if there are any examples of single-story warehouses. There are. I just don't have any. But
yeah, we have lots, and if you send me an email, I can definitely get that.
So Martin, if you want to send an email to Brian Hall at CPCI, he can get you that information. Also, there's another question. I'm trying not to miss everybody here. In residential buildings, we have a lot of shafts. How do you coordinate them? Again, if you go with the ABC approach, you can actually consolidate a lot of those shafts and keep them fairly simple. You actually end up with a better plug-and-play system. instead of having it spread all over the place and lack efficiency and ruin floor space and so on. So you're going to see designs change a little bit too, where you actually end up with a better building, a better layout. And so that's how it's handled, where you centralize a lot of this design and you end up with shafts that work better and easier to maintain. So residential buildings, whether they're multifamily or even single family, we can straighten that out by, again, it's a different approach, a paradigm shift in even design. I think, because I answered a lot of them earlier, just while I was going through it, so I didn't bring them up, but I could revisit them just very quickly so I can clear this. Yes, we're going to get a recording out for this, so you can view it later. That's something that CPCI will take care of. We had case studies in the proposal. There are more available. If you get a hold of Brian at CPCI, he can provide you specific case studies if you have a project you're looking at on this. Sound transmission is some of the big things that is worked out very early on the modular construction, regardless of the type of modular construction. And because of the modular basis of any kind of construction, it actually does a very good job of minimizing or eliminating any sound transfer between units. So it's,
yeah, and Ken, just to mention, we have been working with the National Research Council in Canada, and if you go to our website under resources, there's great technical information on sound transmission that was just recently done. So
the Delta Beam especially is very good at shear. I don't have all the details on that, but the engineers do have that all worked out. So it's a great question, Brett. This one here, what I mentioned earlier, I believe that the R20 in the walls is I said it was an effective value, I think. Trying to remember what I said now. Anyhow, the point of the matter is you have very little thermal bridging, if any, in modular construction. It's designed to actually defeat that. So you actually end up with a better quality R20 than in situ construction typically. And of course, the seismic resistance is equal to, if not superior to, any site-built construction. They have detailing and connections specifically there to handle it. One of the things that modular does allow you to do is it allows you to have the right mix of both flexibility and rigidity in construction so that buildings survive earthquakes much better. You can have site-built concrete where the rigidity is such that the concrete fails at the connection at the lowest level. All you're left there is some rebar that just pivots and falls down. Your building falls over. You don't have that with modular construction. It's all designed to work together.
yeah, and Ken, as far as the R values are concerned of insulated wall panels and so forth and architectural panels, the new software that we developed, and of course we paid for the development of the software, but it's independently done by RDH Building Consultants, and that will be available probably in the next few weeks and so forth. So you just check back to our website in the next few weeks. And by the way, all of this software, our best practice guide, our design manuals, all of this stuff is all free and is available on the CPCI website.
Right. So obviously precast is a natural choice if you're looking at ABC, but it's not the only choice. Certainly, I like using the products that CPCI members put out and recommend it in the right situation, but I also recommend hybridized systems or other systems that are out there. Every time we've approached projects on the ABC system, we've seen benefits. And it's a matter of how much of that benefit can you actually capture. And it's about thinking about it early and getting engaged early and structuring your process of your project early enough to capture all these benefits. So on that note, I have nothing more I can say. I've got my rah-rah in.
Well, that's great. I would like to thank our speaker, Ken King, and thank everyone for attending today's presentation. We hope you enjoyed it. And if you do have any additional questions or comments after the webinar, we do invite you to communicate with CPCI at info@cpci.ca. And again, as we mentioned, the video presentation of today's session will be available in the next week or so, and you will be receiving this by email once it's ready. So thank you again and have a wonderful afternoon.